Alright, so for today's video, we are going to discuss another session for Chapter 6 in our Pure Maths 1. I'm going to cover the topic, the subtopic, geometric sequence. Alright, so I believe that geometric sequence, you also learned it before in your secondary school. So again, we are just going through very quickly to revise all the related formulas that we are going to use. Alright, okay, so now different from arithmetic progression, so geometric sequence is actually a number, a sequence of number, that means a set of number where any term can obtain from the previous term by multiplying by a certain number called the common ratio. Alright, so for arithmetic progression, we're having common difference because the number is actually difference or addition, okay, from term to term. Alright, so for geometric sequence is different, so it is by multiplying a certain number. So that certain number we call as common ratio. So for a ratio, the standard symbol is R. Right? Okay, so again, similar to arithmetic progression, A is the first term and R is the common ratio. Alright, so the first term is A, this is T1. AR will be the second term, which is T2. The third term you need to multiply the R again, so you're having AR squared, therefore that is T power 3, T3, term 3, term 4, and so on. So if you compare the number of the term here, it is R power 0. Then when you're having 2, then it is R power 1. When you're having T3, when the value is 3, then the formula is AR power 2. So in short, when you are having Tn, the general formula will be AR power n minus 1. So this is the first important formula for geometric sequence or geometric progression. Alright, so please try to remember this if let's say you can. If you cannot, then it is also provided in your formula booklet. Alright, okay, then now how to get the common ratio? So again, to get the common ratio, the general formula will be Tn divided by Tn minus 1. So the concept is getting from you get the second term divided by the first term, or you get the third term divided by the second term. Alright, therefore in general it will become Tn divided by Tn minus 1. Okay, so this is how we actually get the common ratio. Right, so again, another important formula that you should know. Okay, then next one. Besides the general term and also the common ratio, you also need to know the sum of the first n term. So when you're having the sum of the first n term, the formula is Sn equals to A 1 minus R power n divided by 1 minus R. Alright, so please take note that the R cannot be equals to 1 because if let's say R equals to 1, then this is not geometric series anymore. Alright, R must be a number which is not equals to 1. Okay, alright. Okay, so this is the formula for the sum of the first n term. And I believe that some of you maybe still remember last time in SPM, maybe you learned another formula like this. The sum of the n term is A, and then R power n minus 1 divided by R minus 1. And then they actually give you, maybe they give you a condition that your R in this case must be greater than 1. Alright, and then after that, you are having 1 minus R power n divided by 1 minus R, and then R is smaller than 1. Maybe in last time you learned these two, they actually separate it into two different conditions. But actually what I want to tell you here is, for A-level syllabus, right, actually no matter which formula are you using, you're actually getting the same answer. Alright, so that's why in the formula booklet, they only provide you one formula like this only. They are not going to give you this one. Because no matter which one are you using, they are still the same. You will still get the same answer eventually, right? Okay, then this is what we have for the sum of the n term. And then there's another formula which is only specifically appear in geometric progression. It is the sum to infinity. Alright, so we are having this sum to infinity for only a geometric series. If let's say you're having arithmetic progression, there's no such thing like sum to infinity. Okay, right, so we are having a geometric series here. Okay, so to get a sum to infinity for a geometric series, it is S infinity. Okay, equals to A divided by 1 minus R. So this is another formula that you should remember. Okay, but please take note that if you want to find the sum to infinity for any geometric series, that means you want to apply this formula, you have to make sure that the modulus of R must be smaller than 1. What does this modulus R smaller than 1 means? It means that it is between the value of -1 until 1. That means your R should be between -1 until 1. Only you can apply this formula and get the sum to infinity. If let's say your R is more than 1, okay, that means this sum to infinity actually doesn't appear. Or even if let's say you really apply this formula, the answer that you get will be a wrong one. Alright, so to make sure that this formula can be applied correctly, you have to again make sure that your R, your common ratio, is between -1 and 1. Alright, so please make sure that you take note on this part. Okay, right. Then after that, you need to know also when your modulus are smaller than 1, we call the geometric series as converge or convergent series. Okay, so again, please make sure you remember this term. So you see the word converge, it also tells you that the modulus are smaller than 1. So again, the modulus are smaller than 1, it means R is between -1 until 1. Alright, so if let's say modulus R greater than 1, it is in the opposite way. That means we call it as a divergent series. Okay, so we call the series, geometric series, as convergent series or convergent when modulus R is smaller than 1. So all these are some important formula for the geometric series. Alright, so maybe we can have a look and see how we actually try to apply it in the exam style question or some example. Right? Okay, so let's start with example 10. Okay, so here they tell you that the first 3 terms in the geometric series are 144, x, and also 64, where x is positive. So again, so please take note that x is positive. First, they want you to find the value of x. Okay, so they say first 3 terms, you're having 144, you're having x, and you're having 64. Alright? Okay, so now, how can I find the x? You can try to use the r actually. How can you get the r? R is the second term divided by the first term, right? So you're having x divided by 144. At the same time, you can also get the R by using the third term divided by the second term. So it is also equals to 64 divided by x. So if you combine these equations together, you're having x divided by 144 equals to 64 over x. So what do you have actually? So try to group all the x to one side and you should get 9216. And then by taking the square root of 9216, you have 96. So x will be equals to 96 here. Alright, so please take note that we are going to ignore the negative 96. When you take square root here, you should have positive and negative 96, right? So if you ignore the 96, negative 96 is because of, in this question, they already mentioned that x should be a positive value. So that's why we ignore straight away the negative 96 here. Alright, okay, then now we proceed to part number 2. They want you to find the sum to infinity of the progression. Alright, so before you find the sum to infinity, first, please try to get the value of r first. So what is the value of r? Okay, just now you know already, it's x divided by 144. Therefore, it is 96 divided by 144. So what do you get here? You should get 2 over 3. Alright, so you'll see that the value of r 2 over 3 is between -1 until 1. That's why they actually can ask you to find the sum to infinity. So what is the formula for sum to infinity? It is actually a. So a is a 144 first term divided by 1 minus r, so 2 over 3. Then by using the help of calculator, I think you can straight away get an answer, which is 432. Okay, so this is how we actually try to apply all the basic concepts for geometric progression and to answer the question. Okay, so we can proceed to the next example if let's say you have no problem with this. Yeah, all right. Okay, so let's have a look for example 11. Okay, so again, this question already tell you that you're having a geometric progression, and then all terms are positive. So again, remember that you're having all positive terms. Has sum to infinity 20. So this is the first information, which is very useful one. Right? So they tell you that the sum to infinity is 20. All right, and after that, the second information is the sum of the first two terms is 12.8. So this is the second important information as well. All right, so they want you to find the first term of the progression. So again, first term is A. They want you to find the A for this geometric progression. All right, so to find out the A, I need to use the information given in the question to start with. Okay, so first you're having the sum to infinity, which is 20. All right, so sum to infinity is equals to 20. Okay, so recall back, what is the formula for sum to infinity? It is A divided by 1 minus R. Do you have the value of A? You don't have. Do you have the value of R? You also don't have. So you just keep it in the formula form like this. So this is our first equation. Okay, and then the second information is the sum of the first two terms is 12.8. Alright, so if let's say I want to get the sum of the first two terms, there are two ways. So some students will say that, okay, sum of the first two terms is S2 equals to 12.8. So according to the formula that we have before, we are having A and then 1 minus R squared divided by 1 minus R, which is equals to 12.8. Okay, so this equation looks like a bit complicated. So if possible, I wish to simplify it first before I can continue to get a solution. Alright, so I want to simplify this part. Okay, so to simplify this part, 1 minus R squared, you can rephrase it become 1 minus R and also 1 plus R. Then divided by 1 minus R equals to 12.8. So if from here you can actually simplify the 1 minus R and 1 minus R together, then you're having the second equation where A 1 plus R equals to 12.8. And I will make it as a second equation. So to me, I think you can simplify like this if you want. Okay, so if you don't want, then how can you solve it? There are still other way to solve it also. Okay, there are other way to solve it also. So it depends on how you are going to solve it. Okay, all right. So what I get is like two equations here. Therefore, to get the A and R, I need to have simultaneous equation. Okay, so before we continue, just to recall back this step, maybe some students will ask, how can I get 1 minus R squared and I to change it become 1 minus R and 1 plus R? Okay, so this one, generally you use a formula that you learned previously. X minus Y squared equals to X minus Y and also X plus Y. Alright, so this is a formula that you learned before in SPM. Therefore, you are applying it here. Okay, so 1 is actually 1 square. R is R squared, so that's why I can expand it like this. Okay? Alright, so now, let's have a look. Okay, so how can I solve simultaneous equation? Right, so from here, I know that A is 20 times 1 minus R. So for the A here, I replace it as 20 1 minus R. So this is the A. Okay, and then 1 plus R, you just copy it as 1 plus R, which is equal to 12.8. Okay, then if you try to simplify all your terms here and try to get the value of R, you'll see that your R is 0.6. Alright, so we know the R equals negative 0.6 because here, again, in the question, they tell you that all terms are positive. Your R positive, then only all terms are positive. If your R is negative, then it will become one term positive, one term negative alternately. Alright, so that's why we straight away ignore the R equals to negative 0.6. Okay, and then for this question, they actually want us to find the first term, not the R. Therefore, you should continue another step to get the A. So what's the value of A? It is 20 multiplied with 1 minus R. So 1 minus 0.6. So from here, you can get the value of A easily, which is equals to 8. Alright, so again, for this question, the question already provides you some useful information, and then you just try to apply formula and solve simultaneously. Alright, so to me, I think it's quite simple and also straightforward. Yeah, alright, so this is another example for geometric progression. Alright, then now, because in our syllabus we are having both arithmetic progression and also geometric progression, so actually it is quite common that they will combine both topics together and ask in one question. Okay, so we can have a look for the next example. Example 12, it is a puzzle question actually. Okay, they actually try to link the arithmetic and also the geometric progression together. And then you need to apply all the formula that you learned in these two subtopics to get the answer. Alright, so we'll start. Okay, so first they tell you the first term of an arithmetic progression is A, common difference is D. Okay, write down expressions in terms of A and D for the fifth term and also the 15th term. Okay, so for first part, we'll start with first part first. First part is very, very simple. We are having the arithmetic progression. Therefore, the T5, what is the formula for T5? It is equals to A plus N minus 1. N minus 1 becomes 4, so you're having A plus 4D. Okay, so how about the expression for T15? The 15th term. So it will be A plus 15 minus 1 becomes 14. So A plus 14D. So this is what you have for part number 1. Okay, then now we go for part number 2. Alright, so for part number 2, they tell that the first term, 5th, and also the 15th term of the arithmetic progression are the first 3 terms of a geometric progression. So they want you to show 3a equals to 8d, and after that they want to find the common ratio of the geometric progression. Alright, so we will start to set up our question first. Okay, so I have a look for this one. From here, if you look at it in a detailed way, okay, for arithmetic progression, I'm having first term, which is A, fifth term, which is A plus 4D, and also the 15th term is A plus 14D, right? Okay, they are equals to the geometric progression first 3 terms. So for geometric progression, first 3 terms is A, second term is AR, the third term is AR squared. So if you compare it like this, that means what do we have here? We are having, okay, A plus 4D is equals to AR, and then A plus 14D is equals to AR squared. Okay, and then by having these two information, they want you to show that 3A is equals to 8D. So I will start from here. Okay, so first I write out like A plus 4D is equals to AR. Alright, so this is the first equation. And then after that, I'm having A plus 14D equals to AR squared. This is the second equation. Alright, so now, in our question here, we want you to show 3A equals to 8D. That means in this equation, there's no R. Alright, so in our equation here, we are having R here. So to get the answer that we want, our aim is to make the R disappear. Alright, so we want to make the R disappear from here. Okay, so I will start from this part. If I move the A over, I'll have R equals to something. Okay, so I will start from here. I will substitute equation number 1 into equation number 2. Okay, so I'm having A plus 14D equals to A Okay, how can I substitute the R? The R is actually A plus 4D divided by A, and then square. So this is the R from equation number 1. Okay, you bring it over, so you have A plus 4D divided by A. Alright, okay, so from here you can see that, okay, your R disappeared already. So what you need to do is like just try to simplify it. From here, expand the square and so on. Then eventually you will get 3A equal to 8D easily. Alright, so maybe for now you can pause this video for a while and try to complete the steps that I skip here. Okay, so expand this square, try to simplify everything and can see whether you can get 3A equals to 8D or not. Right? Right, then the third part. For the third part, you're going to find the common ratio of the geometric progression. Okay, so how can you find the common ratio for a geometric progression? So again, now they want you to find out the R. Okay, so maybe to find the R, I can use the first equation here. Okay, so your R is equals to A plus 4D divided by A. Okay, all right, so how can I get the value of R? Again, do you still remember that in part number 2, we already proved that 3A is equals to 8D. Right, so 3A is equals to 8D. Therefore, you can actually try to make it like this. A plus 4. What can I have for the D? The D is actually 3 over 8A. From the equation that we proved in part number 2. D is equals to 3A over 8, and then divided by A. Right, so if you add them together, you're having 3 over 2 plus 1, which means it is 5 over 2A on top, then divided by A. A and A can be cancelled off, and therefore your common ratio is 5 over 2. Alright, so again, I don't know whether you can see the style or not. I told you before in class, right, when they ask you to prove some result or show some result, usually you need to apply the result in your next. Alright, so this is how you apply it. Okay, so this is example 12 where they try to combine both arithmetic and also geometric progression together. Alright. Okay, so I hope that there's no question for you all, but if let's say you have any question, of course you can ask me anytime from Facebook Messenger. Okay, alright, so let's continue with the last example of this video. Okay, example 13. Alright, so for example 13, it involves profit. Okay, for a trading company, or maybe some question they will involve interest for bank. Alright, so if you try to go through it now, you are having a profit of 250K in a year, 2000. And then the company considered two different plans, Plan A and also Plan B, for increasing profits. Okay, so under Plan A, the annual profit will increase each year by 5% of its value in the preceding year. Okay, so they want to find for Plan A the profit for the year 2008. Okay, so again, when you need to solve this kind of question that involve year one, then usually before that, I will want you to set out the question first. I will prefer you all to write out the year. Okay, so that means the year starting is year 2000. Alright, then after that, you might have year 2001 and so on. Okay, so before that, for year 2000, what is the profit that you have? You are having 250K. Right, then for year 2001, it increased 5% of its value in the preceding year. So if it increased 5%, that means you need to multiply with 0.5 with 250 and then add 250 again. So for maths, usually what we write is that it is 250, 5% is 0.05, right? So that means the total profit for year 2001, it will be 1.05. So maybe you want to say, why is 1.05? I thought it should be 0.05, right? Okay, 0.05 is the increased value, the value increase for this particular year. And you need to add back the profit for the previous year, right? 250 is included, right? Therefore, the 1 is actually the 100% for 250. Okay, therefore, when you write out, you become 1.05. Okay, so how about for year 2002? So for year 2002, you can actually see that it increased 5% again. So that means it is 1.05 multiplied with 1.05 again. So that means it's square. Okay, so I don't know whether you can see the pattern or not. If cannot see, then we continue further. For year 2003, it will be 250,000 multiplied with 1.05 power 3. And so on. Okay? Alright, so now, once you set up already, then please have a look for this. They want you to find the profit for the year 2008. Okay, so why I want you all to write out the year when you set up the question is because of you can see the pattern in a clearer way. Alright, so as an example, you can see for year 2000, we name it as T1, the first term. Alright, for year 2001 is T2. For year 2002 is T3. 2003 is T4, and so on. So can you tell me what is the number of term for year 2008? So this is not T8, but it should be a T9. So that's the purpose why we want you to write out the year. You can compare it with the term, and then you can see it very clearly. Because some students might get confused. They thought, oh, year 2008 should be T8, but actually it is not. It should be a T9. Can see that? Okay, so now, how can I find out the formula for T9? So again, from the setup of our question, you know that the A is 250K, and the R is actually 1.05. Okay, because you see, the difference for every year is by multiplying the 1.05, right? Therefore, the common ratio here is 1.05. Okay, so you're having T9, which is equals to A R power n minus 1, which is the 8. Alright, so from here, you will get 369,363.86. Alright, so because this question involves money, so usually I will put it in 2 decimal places. And to me, I think this is not secure enough because you know the number looks like very, very weird, right? Okay, so I will change it and round it off, become the standard term that A-level 1, which is 369,000. So I will rephrase it in 3 significant figures. So your T9, the profit for the year 2008 will be 369,000. Okay? Alright, then after that, they ask for the total profit for the 10 years from 2000 to 2001 inclusive. So they already tell you that they want to get the sum for 10 years. Total means sum, right? So sum for 10 years, the n is 10. Okay, so this question, it will be very straightforward. Okay, so how to get S10, the sum of the first 10 years. So again, you're having A, this is A, and then 1 minus R power 10. Okay, then divided by 1 minus R. Alright, so it's very, very straightforward. And then by just pressing calculator, you should be able to get this as your sum. And again, I will round it round it off, become 3 significant figure, which will become 3140000. Alright, so these are a few examples that I can take it out from the past year question so that you can see how we actually try to um, solve the question for geometric progression. So of course there are a lot more different types of questions, so it needs some time for you to figure it out and then you try the past year by yourself. Okay, so if there are any question, you can always drop by the message from Facebook Messenger or maybe from email, okay, so that I can solve the question for you. Alright.